Hello students, today we will derive an expression for the diameter of bright and dark rings for the Newton ring experiment. Now in order to derive an expression for diameter, first we have to understand few properties of circle along with chord theorem. So let us consider the ring that gets formed for my Newton ring experiment. Newton ring experiment. This is the circle. It is having a center at C, and suppose this point is G and this point is O, and this is my plain glass plate, which is POQ. Now center of the circle till this distance will be radius of this circle. The same will go here, radius of the circle. But for Newton ring experiment, the air film is of wedge shape. So let us take this of thickness. What was the thickness of my air film? We can take another chord like this. Now we are taking chords because we have to derive an expression for diameter of the rings that are formed. So let this be the thickness of the air film. And now this is T, thickness of the air film that has formed. This R is the radius of the nth ring, or whichever ring you want to consider. Radius of nth ring. Suppose we are taking only one ring into consideration while we are deriving our expression. So see, this is T, this is R, this is R. So this total distance is 2R. Twice of radius of this big circle. Small r is the radius of the nth ring. Like in Newton ring, we get rings like this. Now, this distance OE and here, they are all 3 are T, thickness of the thin film, wedge shape. And a specific one ring we have taken. So, this remaining distance GE is equal to 2R minus T. 2R is the total, this is T, so this is 2R minus T. Now we know from the property of a circle or the chord theorem, which states that the product of the length of line segments on each chord are equal. We will pick up EF here, F is this point, EF into DE, they are both chords, is equal to OE into EG, all chords from chord theorem. From chord theorem of a circle, EF into DE is equal to OE into EG. EF into DE is equal to OE into EG. Now, let us see EFED. EFED is radius of my nth ring. So, EFED is radius of the nth ring. OE is the thickness of that specific ring for the wedge shape ring, that specific one particular ring about which we are talking, into what is EG? EG is 2R minus T into 2R minus T. So we will solve this. R square is equal to 2RT minus T square. Now, for a thin film, this thickness of film and obviously our topic is thin film. So this T is already a very small quantity, and the plano-convex lens which we take, this R is a very large value. Sorry, the radius of this is a large value, sorry. So the T square quantity becomes all the more less than R. Then we can neglect the T square term here, and we get R square is equal to 2RT. We have neglected this because it is a very small value, and this implies that T is equal to R square upon 2R. That is the thickness of that specific film whose radius is small r. Now quickly, with this value for maxima and minima, how will we find maxima and minima in this case? We will pick up the path difference that has occurred between the rays, and for maxima, that is the bright rings or the constructive interference, 2 mu T into 2n minus 1 lambda by 2. So putting T, which we have just derived as R square upon 2R, 2 mu R square upon 2R is equal to 2n minus 1 lambda by 2. So R square becomes equal to 2n minus 1 lambda R. This 2 and this 2 have got cancelled. R I have taken above, divided by this 2 mu has come down. Now this is R square for a medium of refractive index mu. If it is, you can even find the value of diameter here. See, this radius is what, half of diameter. So the nth ring, if it is passing through point F of this film here, and R should be the radius of the nth bright ring. So I can even write Rn square is equal to 2n minus 1 lambda R upon 2 mu. And what is radius? Radius is half of diameter. So I can write Rn is equal to dn upon 2. The diameter of the nth ring. I can write it for that easily. So Rn can be written as dn upon 2, half of diameter. So Rn square is equal to 2n minus 1 lambda R upon 2 mu. So dn square is equal to 2 into 2n minus 1 lambda R upon mu. So diameter of nth ring is under root 2 into 2n minus 1 lambda R upon mu. For air, you can put mu equal to 1 and the diameter formula becomes under root 2 into 2n minus 1 lambda R. For this value, diameter of bright here. Now if I take this formula for air, a very interesting conclusion comes out that if I take the case of air, then diameter of the bright ring will be dn is equal to under root 2 into 2n minus 1 lambda R. I have put mu equal to 1, and then if I put, I assume k is equal to under root 2 lambda R for n equal to 1, 2, 3, etc. So dn is k times of 2n minus 1. Diameter of bright rings are getting proportional to the square root of odd natural numbers. It is getting proportional to the square root of odd natural numbers. Now, for the dark rings, let us put the formula for path difference. Dark rings, For dark rings, we put the value of T equal to R square upon 2R in the formula of path difference for dark rings or minima. For dark rings or minima, it is 2 mu T is n lambda. T we put equal to R square upon 2R. So R square upon 2R is equal to n lambda, and then R square is equal to n lambda R upon mu. Once again, R I can write it as half of diameter. So this can be again written as dn square upon 2, dn square upon 2 whole square is equal to n lambda upon mu. So dn becomes equal to under root 4 n lambda r upon mu. Now for air, I can take mu equal to 1. So dn becomes equal to under root 4 n lambda r. 4 n lambda r. For air, mu is equal to 1. So dn becomes equal to under root 4 n lambda r. Let this make it proportional. Put k equal to 4 lambda r. So it becomes k under root n, where k is under root 4 lambda r. Now here you can put n equal to 0, 1, 2, 3, etc. Now if I do one more very interesting conclusion, dn plus 1 minus dn is equal to k into under root n plus 1 minus under root n. So the spacing between the consecutive rings is obtained by putting n equal to 1, 2, 3, etc. And then see, d2 minus d1 is k into under root 2 minus 1. This comes out as somewhere k into 0.41. d3 minus d2 is again somewhere as roundabout k into 0.32. This way, then you keep increasing like this. So you will note that, see, the value is getting decreased from 0.41, 0.32. Then further it will be 0.27, 0.23 like this. So the spacing is decreasing with the order of the rings. Fringes get closer and closer as their order is increasing. Now, how will you find the wavelength of the sodium light for this experiment? Now you know the maxima and minima. Now you have to find out an expression for wavelength of the light. So let dn and dn plus p be the diameter of the specific rings. That is, dn square is 4n lambda r. dn plus p is dn square is equal to 4 into n plus p lambda r, right? And p is any number of the fringe which you are studying under. Subtract them. dn plus p square minus dn square is equal to 4 into n plus p lambda r minus 4n lambda r is equal to 4p lambda r. So your dn, the lambda is equal to dn plus p square minus dn square upon 4pr is wavelength of the monochromatic light in Newton ring experiment. Thank you.